Okay, so I think they're shutting the doors, and we're going to get started here in a second. I unfortunately also have a MacBook, which instead of wasting 15 minutes of time like my colleague, I transferred everything over to a borrowed computer, so I have my slide deck. I had a pre-recorded demo from another presentation, so we'll see how that goes. I've got some screenshots and I have some source code, so improving a little bit. I was furiously trying to record stuff and type when I was sitting there in the audience and I saw what happened, so hopefully, if anything goes wrong, cut me a little bit of slack as well. This is Building an Empire with PowerShell. My name is Will Schroeder. My Twitter handle is Harmjoy. And so I feel at this conference I'm definitely a little bit of the odd man out. So my day job is I usually do pretty unethical things with computers on a daily basis. I'm a professional hacker. I'm a professional red teamer. I've also kind of been dragged kicking and screaming more into development, so I've built a large number of the tools that we use to attack networks. And I'll get into some of kind of the ethics of offense and all that in just a little bit. So the overview, just a little bit kind of on our offensive philosophy and how we approach engagements, and really why build something like this, because I'm sure there are plenty of people in the audience that are not, probably don't morally or ethically approve of building offensive attack tools and then open sourcing them, but I'll kind of explain why we believe it's the right thing to do and why we do what we do. I'll go over Empire itself, some of the existing offensive PowerShell tech or projects that are out there, a little bit about the architecture of Empire, what is it, how does it function, how do the communications function, like what's the whole point. I'll try to show some of the source code of the core agent itself, as well as some of the staging components. I'll cover a few of the modules in the demo so you can really see the power of this. And I'll go over just a little bit on detection. Because I come from kind of a different subfield with security, a lot of the terms and things and acronyms that I use, I realize some people might not be familiar with. So I'm going to try to explain as much as I can and kind of get everybody on the same page. But if anyone has any questions, even during the presentation, please don't hesitate to ask. Especially in some of these slides, I would love to have a conversation either through Q&A during the presentation or in our breakout session after. So, our offensive philosophy. There was a great Microsoft red teaming white paper that came out last year. I believe it was called Microsoft Enterprise Cloud Red Teaming. And it was 40 or 50 pages. I definitely recommend people reading it if they're interested in this type of stuff. But in it, they describe this mentality that they call assume breach. This is really a new way that companies have started to think over the last few years, because up until 2010, like you guys work on day jobs, DevOps, sysadmin, and everything like that, most companies thought we're secure, we're not seeing alerts and bad stuff, so therefore we're fine, right? What we're actually realizing is that if your company has anything of interest that someone would like to steal, specifically a state government, you're probably already owned. There's probably someone in your network. If you have interesting source code, it's very difficult to protect against an adversary that has billions of dollars, teams of hundreds of people in a nearly infinite time frame to do this type of stuff. So when we do red team engagements, we have 2 or 3 guys or 2 or 3 weeks, and we're successful probably 95, 99% of the time in achieving our objective. And we're going up against very large enterprises with a lot of different detection capabilities, a lot of commercial products. Things can kind of be headaches for us. They can slow us down, but nothing has really stopped us. But in that white paper, there's this great quote from Michael Hayden. He's the former director of the CIA and NSA, which I realize, putting a quote from someone that used to work for the NSA and coming to Europe might not be the best idea, and some people are probably going, eh. But the quote is great, and it says, fundamentally, if someone wants to get in, they're getting in. Except that what we tell clients is, number one, you're in the fight, whether you thought you were or not, and number two, you're almost certainly penetrated. What this isn't about kind of having a nihilistic worldview. It isn't about, just throw up your hands and say, there's nothing we can do, we're all owned, whatever. It's about changing the way you think about what attackers actually do, and in this specific case, PowerShell, and then think about, okay, if we don't stop them just getting in, how do we put multiple defenses in place that can slow people down, or we can detect them, maybe we can cage them and figure out how to actually handle this adversary. But for example, with PowerShell attacks, you're not going to stop everything, but something like, in version 5 script block logging, a lot of these awesome security protections the PowerShell team has put in, it gives you a huge number of options in how you can actually detect and respond to some of this stuff. So, Empire motivations, why we ended up kind of building some of this stuff. So, if anyone's watching the news and you're interested in PowerShell, you've probably seen an uptick in offensive, like malware in the wild type of PowerShell attacks over the last few years. So there's a famous variant called PowerLix, which is a pure kind of PowerShell-based agent. Some of the, like Deep Panda and some of the APT advanced adversary groups have started to much more heavily use PowerShell itself. This one was pretty recent, the PowerShell increasingly being used to hide malicious activity. Is something some recent kind of defensive company released that 23% of the adversaries they observed were using PowerShell in an offensive context. And Matt Graber, who's also a PowerShell MVP, spoke at the US Summit. Sorry? 38. Oh, 38. Oh, okay, sorry, Jeff. Yeah, correct. So Matthew Graber, who spoke at the PowerShell Summit and is also PowerShell MVP and is actually my boss at my company, had said, my offensive PowerShell awareness campaign can wind down now. It would seem that criminals and state-sponsored actors have it from here. So one of the things I want to kind of stress with this is that, these aren't really like, people are using PowerShell, but this isn't a PowerShell attack, it's not a vulnerability. So a lot of the really useful features that PowerShell gives you from like a system administration standpoint can be used, it's just a tool that you can use, right? So you can use it for good or you can use it for bad. A lot of red teaming is kind of unauthorized domain administration, or if you're an unprivileged user, how do you find the misconfiguration and flaws in a network? And we can use PowerShell to accelerate some of this. I love that quote. Earlier, Tobias had mentioned of, if you can think that PowerShell can do something, it probably can. So we started thinking, would it be possible to write, kind of as a thought exercise, could we write a fully functioning piece of malware purely in PowerShell? Now, the question on a lot of people's mind is, okay, even if you did that, why would you release it? So I've been a hacker, for about 7 years. I've been writing PowerShell for a couple of years as kind of an outsider being brought in. But my belief is if we want to help secure companies against the level of threat they've been unknowingly facing for decades, then we need to have some tools and techniques that let us simulate some of the actions of these more advanced adversaries. If all of the offensive, kind of bad stuff stays private and only the bad guys can have it, then good guys like our consulting company don't have the tools that they can kind of simulate these actions to commercial companies. So if we don't have the tool sets, like how do we simulate a Deep Panda or something like that? We're never going to perfectly simulate what it actually is, but how do we even mimic it if there isn't stuff out there that lets us do this? Now, that's one side of it. The flip side is, there's a balance between making tools that help simulate these threats and providing help to the real bad guys. So the ethics of it and kind of going back and forth is pretty similar to the gun debate, which kind of happens in the US a lot and in different other parts of the world, but just because you have a gun or a weapon that can be used by good or bad guys, do you just outlaw it for everybody? Is that going to make everybody safer? Is that going to make the populace safer if bad guys can still procure it? It's not. My whole thing with this is there's not a black and white answer. It's very kind of gray, it's in the middle, but it's something that we do think about a lot. We do keep some of the stuff that we develop private. We open source a good portion of it, but we aren't aiming to just arm the enemy and give all the bad attackers all this crazy stuff to attack your network. So existing offensive PowerShell, there's a lot of projects over the last couple of years. Actually, well, by a lot, I guess, kind of 2 or 3 main ones that have started to pop up. They give you a lot of really interesting kind of offensive bad type stuff that you can use with PowerShell. And the reason this really kind of came about, and like kind of PowerSploit, which I'll get into in a second, came about, is, we really like the philosophy of living off the land. So if we're an attacker and we gain access to someone's machine, we want to use things that are built into the machine to, facilitate our attacks and kind of, keep propagating. So PowerShell is great for this. It's a Microsoft signed binary, it's on the system, you have access to .NET, you have all this awesome stuff that, why we all love the language. So why would attackers not like it as well? So PowerSploit was a project started by my boss, Mac Raber, about 3 or 4 years ago. And it's kind of the gold offensive standard as far as projects go. We actually have pester tests for all of our offensive PowerShell code, which is kind of cool. It was very interesting to try to figure out how you, mock up, injecting shell code and keylogging and doing all this kind of crazy stuff. We started doing the pester test. We still have a long ways to go, but we want our bad offensive code to be stable and unit tested, just like normally good code. But it is a little funny, I guess. But some of the stuff that you can do with PowerSploit, you can enumerate, manipulate tokens. You can inject what we call shell code, and if you're not familiar with that, it's essentially position independent assembly. So if you take this kind of shell code, and one of the things we'll do is we'll inject a small piece of code that we call a stager into another process, which will then reach out, grab the full agent capability from what we call a command and control server. It'll download the agent, do encrypted communications, and it'll show kind of how that works with Empire, and then lets you take taskings from your control servers and attacker and run them on the client. We can do keystrokes, screenshots. A project that I wrote called PowerView does a lot of advanced kind of AD, recon, and enumeration. I have a session on that tomorrow. PowerUp is another tool that I wrote that automates a lot of those Windows privilege escalation type checks, which if you're interested in Privest checks, talk to me after or something in a breakout, because we have a lot of clients that actually use this to audit their gold standard images and enterprises. So it checks, vulnerable services, vulnerable service EXEs, DLL path hijacks, kind of the encyclopedia of public misconfiguration type privilege escalations. So a lot of our clients, after we assess them several times and find some issues, they actually integrate this into their kind of gold image provisioning process. So a lot of really cool stuff. And then about 1.5 years ago, I realized this is all the functionality of a kind of what we call a remote access tool, a remote agent. We have all the little bits and functionality that really exist in these projects in other languages like C, but there was no PowerShell agent. There was nothing that kind of bound everything together and gave you encrypted communications and kind of that weaponization component. That's essentially what Empire ends up being. Oh, and the best thing in PowerSploit that I didn't even mention yet, but invoke Mimikatz. Has anyone not heard of Mimikatz? Anybody? Okay, just a couple of people. So has anyone used Mimikatz? Okay, awesome. I was expecting there weren't going to be too many people that had. So I have a quick recorded demo where I walked through the ISC. I recorded this 5 minutes ago, or 10 minutes ago, and we'll see how this goes. Mimikatz. Cool. So basically what I'm doing here is we use something called the download Cradle a lot. So it's this pattern of IEX, new object, net.web client, download string from an offline, and then like a URI to another site. And essentially, IEX, invoke expression, new object, net.web client, create a web browser, and then download the script resource as a string and evaluate it as code. So this is essentially how 99% of attackers run PowerShell on a system without touching disk. So they'll, have either some people do it straight from GitHub, which is terrible, but if you have a server you can control that you put your malicious code on, you can run this and load everything up in memory. So execution policy never enters into anything, which not that it was a security protection anyways, even though plenty of admins believe it is. And you're not touching disk, you're not having AV scanning anything, and up until PowerShell 5 with the AMSI, the anti-malware scan interface, and a lot of these other awesome protections, which I'll cover a bit, there wasn't really a way for defenses to really kind of combat this really well. And a huge credit to the PowerShell team. They like Lee Holmes actually interacts with us hackers all the time. He comes to our conferences, he chats with us, we're friends with them, and he sees what we're doing. Those guys and a large number of other people on the PowerShell team, and I don't know if we're actually I don't know how much we're actually influencing, but hopefully we are just a little bit, because that PowerShell loves the blue team type thing, that post when it came out, it definitely gave us a heart attack a little bit as attackers, but like kind of, the blue side of our hearts were really, really happy that these changes were being implemented. Especially now that PowerShell is, from what we can tell, is the most secure scripting language in existence, or that has ever really existed with all these protections. So anyways, load everything up. I'm just going to run kind of the standard invoke mimikatz, which is going to give us all the plain text passwords from, I'm also running this on a Windows 7 machine, so 8.1 and everything it up. Also integrate a lot better memory protections that keep you from extracting plain text passwords from LSASS like you can in Windows 7. But the wdigest specifically, I believe, is disabled in it is disabled in newer versions of Windows. But with mimikatz, this is kind of the classic canonical example: is you run it if you have administrative rights on the machine, and then you can extract all the plain text passwords from a system. So that's what a lot of people just believe. Okay, you can run mimikatz, you can pull stuff out of LSASS. That's pretty much it. But there's so much more that mimikatz can do. Benjamin Delpy, the Frenchman that writes mimikatz, is a crazy little mad scientist, and he has outside of Microsoft, one of the best understandings of like Windows credential internals I can possibly imagine, because we keep thinking he's done with features, and then the next month they'll just add something new in. So another example is essentially what's called overpass the hash or pass the key. So mimikatz can take a NTLM credential hash and essentially skip the part of the Windows authentication cycle where it's hashed and used to check out a Kerberos ticket, the normal Kerberos authentication component. So with mimikatz, you can overwrite the hash in LSASS. So if you have an NTLM hash of any user, you can turn this into a Kerberos ticket. So, and it's not really past the hash because you're not relaying the NTLM credential itself. So even if you disable older versions of NTLM and blah, 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 and anything else, this will still work because it's taking advantage of the native way that Windows does authentication. But I can spawn a command prompt as any user if I just have just their hash, regardless of whether I have their plain text password. Another kind of cool example, let's see here. Yes? The question was, does this still work with device guard or credential guard? I am not sure. 100%. I haven't personally investigated it. I know many of the newer protections on Windows 10 where I'm sure there's people in Microsoft yelling at other people to say, like, how did this one guy with an open source tool, blah, blah, blah. So there's, beyond just PowerShell security, I personally think, I don't know, someone else from Microsoft can verify that mimikatz is helping to drive and better the security in a very serious way of newer versions of Windows. It does not work. Okay, thank you for the answer. Yep. Yeah, that's it's really cool to hear that. If you know anything about any government, specifically the United States government, them moving to something like that in a massive upgrade, that soon is unprecedented at a massive scale. The United States government still has XP machines, and I think they were the ones that also requested continuing patch cycles, even though it's completely end of life, because there's still a massive number of Windows XP machines in any state government. One of the cooler, newer features that some people might not be aware of is DC sync. So mimikatz can use the native, it takes advantage of the protocol used by Windows domain controllers to replicate information between each other. So you can basically fake out a domain controller and you say, if you have domain administrative rights, or there's certain other rights, if you have the elevated rights to essentially be domain admin, then from any system, even just a Windows 7 system in this example, you can say, hey, primary domain controller, I'm also a domain controller. Can you please give me the password of this user? And it just gives you all the information, or it gives you the hash. So this is a way to extract passwords on domain controllers without running code on the domain controllers themselves. So this is really awesome because it just uses the normal protocol and is really crazy. I've used this in the field. It's pretty nasty. The one way we know of to detect it at this point is essentially seeing like a NetFlow type thing of saying, is this protocol going to this domain controller, not from other domain controllers? I'm sorry, I can't quite hear you. I'll cover the golden ticket here in a second. This is slightly separate to where it's essentially just replicating it's simulating the replication functionality that happens normally between domain controllers anyways. So the last thing that some people have heard of too is golden tickets. So I'm going to take the hash of that KRB TGT account, which, if you're unaware, is the Kerberos signing key in the kind of the architecture of how Windows does Kerberos authentication. And essentially a golden ticket is just a forged Kerberos ticket granting ticket. So if we have the signing key, we can put whatever information we want in the ticket that we create. So we can say we're any user, we can say a part of any group. And the really crazy thing is within a 20-minute window, nothing at all is verified. And after that window, the only thing that's verified is if the user exists. So I have actually heard of people putting JavaScript into the user field in a golden ticket and then doing cross-site scripting on the SIM solution for blue teamers, or defenders, which is pretty crazy. So it's pretty nasty. But essentially, if an organization does not rotate the KRB TGT hash of their organization, which by default only happens when you upgrade from domain functional level 2003 to 2008, I believe. And now Microsoft has a script which is released, but I don't know how officially supported it is. But if you still have this hash and it doesn't change, then people essentially have a skeleton key into your domain indefinitely, because at any point they can just take this hash, create their new ticket again, and then they go from regular user to domain admin, which is pretty terrifying. But beyond those things that people have heard of a bit, I think hopefully some people seemed impressed with the DC sync functionality. There's also malicious security service providers, silver tickets, which are for service tickets, and a ton of other stuff. And what I also kind of glossed over, forgot to mention, is invoke Mimikatz is a PowerShell script that implements the Mimikatz DLL within it. So it's essentially what we call a reflective PE loader. So it can take a specially designed DLL or EXE and load it completely into memory without touching disk. So if you combine invoke Mimikatz with some kind of technique that executes the code in memory, we can run all of this without ever touching disk on a Windows system. The invoke Mimikatz is used in target attacks all the time. It's probably the most commonly used script by attackers on the offensive PowerShell side. So that's my little demo of invoke Mimikatz. And then I'll get into Empire itself. Like I mentioned before, Empire is essentially a RAT, or a post-exploitation agent, implemented completely in PowerShell. It aims to solve kind of what in the attacker community we call the weaponization problem, which is, okay, we have this really cool kind of PowerShell stuff and we want to run it on this system and get it back in a secure manner. So how do we do that? Up until now, PowerShell hasn't really been implemented into any public offensive toolsets. That's starting to change. The most popular offensive toolset is called Meterpreter or Metasploit, which has recently integrated PowerShell functionality. So I think that's going to kind of be a breaking point and show a huge uptick in the usage of some of this offensive stuff. And it's also an attempt to kind of train defenders in how to stop and respond to PowerShell attacks. So because it's implemented completely in PowerShell, it's not the most stealthy thing. I'll go over some of the indicators and kind of some of the noise it makes, but it lets us go up against a client who might not have, they're like, PowerShell, whatever. And we can show them that we can completely compromise a domain using literally nothing but PowerShell. Then they start to take it a little bit more seriously, and we can start moving them towards better defenses that detect real attackers doing this type of stuff. So I have two kind of quick slides on the technical side for how some of the two cooler inner workings of PowerShell work. The first thing is the staging process. So Empire works with a kind of get post structure, get post type structure. So it's going to get just over HTTP or HTTPS. It's going to get a piece of code. The control server is going to return, and then when Empire wants to post results, it'll just do a post to the control server. The control server itself is implemented in Python. The agent and all the post-exploitation modules are obviously PowerShell. So the staging process is, the client executes this little launcher, which I'll show in a second, which is very small, that basically goes to the server and says, give me the key negotiation stager. That is kind of XOR obfuscated. We're assuming that that's not encryption or anything, or it's just kind of an obfuscation component. That returns this little negotiation PS1. That's a small snippet of PowerShell that just does key negotiation in this particular way, and this is called encrypted key exchange, which essentially wraps asymmetric and symmetric encryption together that gives you perfect forward secrecy. So even if this entire exchange is recorded, it's not possible to get the individual agent encryption key in the end out of it. So that client is going to generate private public keys through RSA. It's going to use the AES staging key to encrypt the public key, post that back to the server. The server uses that public key to encrypt kind of like a randomized session key that it returns. But it's like a kind of three-part staging process. And after that, all communications will happen over AES 128, cipher block chaining, all that kind of stuff. So we believe the communications are reasonably cryptographically secure. We haven't had them audited, and it's an open source project, so there's probably some kind of crazy flaw in it somewhere. The really cool thing, I think, is, with some of our kind of offensive friends, we started having this debate of, can we run PowerShell without PowerShell? And obviously a lot of people know, not a lot of people here know, but not a lot of people know in the offensive community, that you can, just using like a C#.NET application, it's really easy to just start up a PowerShell instance and run whatever code you want. But what we really wanted was a way to run our Empire agent in non.NET processes. So someone who now actually came to work for us, but at the time didn't, released a project called Unmanaged PowerShell, which was a C++ program that would load up the .NET runtime and use that to start a PowerShell instance and run whatever code you want. So we took that and essentially turned it into what we call, in the often, people are familiar with it, but a reflective DLL, which is a DLL with some really kind of crazy load library stuff at the front of it, that if you take this DLL and inject it into a process, then that code can run without touching disk. So you don't have to, it's a way to load a library into a process without the DLL being on disk. So we wrapped all the unmanaged code in a reflective DLL and then stuffed that into another PowerShell script. So the end result when we run this invoke PS inject is it'll take this DLL, inject it into the process you want. It can be unmanaged or managed. That loads up the .NET runtime, starts a PowerShell instance, and then runs that little IX kind of download Cradle stuff that we talked about. So we have the ability to run our PowerShell agent, Empire, in whatever process we want, which I'll show in the demo. But I think it's kind of nifty, kind of cool. So now I have some stuff to show. I'll show the demo first, and then I'll go over some of the code. I think I'm doing okay on time. Okay, so you won't actually see a huge amount of PowerShell code itself in this demo, but I'll kind of show you some of the capabilities of it. So this is the Python controller. It's going to zoom in a second. So it's like a text-based UI controller, which all hackers just like writing stuff in Python. So right here, I'm basically setting up a listener with a bunch of configuration options. So this is going to say, I want the agent to connect back, every 5 seconds or every minute or every hour. This is the port. This is the kind of the command and control domain and all that type of stuff. We also have different ways that you can do stagers. So how do you actually get the code to execute on a machine? We have kind of self-deleting BATs, which Jared showed in his investigation demo, and that kind of shows you what it looks like, and I'll show you guys that code in a second. The actual code itself and also decoded, but it's essentially, a PowerShell, no profile, non-interactive, hide the window and use this encoded command. So if you ever see -enc and then something else show up in kind of command line logging or something, it's probably bad guys. 99% of the time, I think, is usually bad guys doing stuff. We also have macros, HTA applications, and kind of a variety of ways to actually trigger this logic. So for the purpose of the demo, I'm going to move this little BAT over. It's going to run a command. It's going to delete itself. And then an agent's going to check in. So that whole process there was basically that key negotiation happening behind the scenes. So now whatever you task to it is going to be over purely encrypted AES communications over HTTP traffic. So very, very similar to how a lot of real malware actually works, or in the wild malware tends to work. So the first thing I'll do is run a module, which is power up in the back end, that will check the system for any privilege escalation vulnerabilities. So it should run. I think it's running. I recorded it, so yeah, I know it works. Duh. I was like, oh yeah, it's a video. This is going to show that this user is actually already an administrator. They're in a local group that grants admin privileges, but UAC is stopping us from actually running interesting stuff. So we have a PowerShell implementation of what's called the bypass UAC attack, even though UAC is not a security boundary. I believe in Windows 10 there is some stuff where like you can only load up like signed Microsoft DLLs to like Windows processes and stuff like that. The canonical bypass UAC attack essentially takes advantage of sysprep and then drops a malicious DLL to disk that is hijacked from like how the DLLs are loaded. So it's hijacked by sysprep and does a bunch of kind of crazy stuff in the back end and gets you in high integrity, which lets you do the interesting stuff with LSAS and whatever else. So okay, now we have a high integrity agent. We're going to rename it. Do a process listing. I'll show you the kind of injecting the agent into a different process here in a second. Cool. So we see that there's a variety of users logged in the system, and we're going to inject our, I don't know why I even chose command. Like for demo, for proof of concept purposes, we've run our agent in LSAS itself, which is kind of weird, but having PowerShell running in LSAS. But we're going to inject the agent into this different process, cmd.exe. And the thing with this that we try to preach to clients is, yes, it's good to lock down PowerShell in reasonable ways and do these protections and logging, but there's probably, attackers can usually find ways around some of these defenses that people put in place. So you don't want to rely on one defense as a silver bullet. It's like in this case, I could shut down the other agents and PowerShell itself would not be running on the system, even though we'd be doing all this bad stuff with PowerShell. So I'm going to run a quick module from PowerView, which is what's being presented on tomorrow. That's going to find where does this user have administrative access in the network very, very quickly. Yep, and also the agent itself has like a job architecture in the back end. It's got fully packetized communication, so it's a reasonably architected kind of semi-mature solution. So, okay, we have access to this primary box, which is domain controller, and we're actually going to use WMI with process called create, which is kind of a standard pattern that attackers tend to use to execute a process in a remote machine. And we're going to use that to substitute in that kind of little stager one-liner that launches the PowerShell agent. So all abstracted out, the configuration, everything. So we're able to establish an agent on a second machine. So privilege escalate, figure out where else we have access, and spread to another machine. So this is kind of indicative of the types of patterns and the types of things that we tend to do on engagements. So I'm going to rename that and get over here. So now I'm going to dump all the hashes on the domain controller itself using mimikatz yet again. Dumping some stuff from LSA. Yep, okay, cool. All the hashes, and there's also a backend credential store for Empire, so it auto scrapes and parses all this stuff out. So now I'm going to go back to a user who does not have administrative access in the domain controller. And then I'm going to, again, use mimikatz, which ends up being like 70% of our kind of attacker functionality, it seems like. I'm going to use that to create a golden ticket, which will give me administrative access to the domain controller again. So golden ticket module, use a stored credential, so you don't even have to worry about configuring everything. And then I'm going to say, okay, we're going to say that this user is now administrator, execute it. Cool, it's going to generate the ticket, inject into memory. Again, a single file has not touched disk except for that little launcher BAT. And now we have administrative access, again, to the domain controller. Oh yeah, you're right, sorry. Bypass UAC does drop a DLL to disk temporarily that then is hijacked. Cool. So now I'm going to try to show you just a couple screenshots of kind of how the staging process worked. So there's a Wireshark capture that shows right when that little stager launched, it's just going to try to get a particular resource path on the server. And that server is going to return a whole bunch of stuff here, which I'll show you decoded in a second. Then it keeps doing its key negotiation. It starts to move from just kind of obfuscated text back to like AES. And after everything's established, whenever you're running commands, this is essentially what it'll look like in the wire. There's like kind of predictable patterns here, and on the defense side, I'll tell you about some of the signatures that have been published. But you know, we don't have the blank user agent, we don't have whatever else, we can do custom headers, but it gets a resource that path can be predefined, and then it returns an encrypted blob of text. It's going to run like a process listening or something that's going to post back a bunch of other AES encrypted type stuff. So let's see what, I think we had the ISC open. Yep, okay. So again, that's kind of what that little launcher looks like, a bunch of weird encrypted kind of whatever stuff. Decoded, that one-liner is essentially just starting up in .NET in the back end a system.net web client. It's going to change the user agent. It's going to pull out kind of the default proxy settings from the system. So as an attacker, one of the things we worry about are super restricted proxies. So if you guys have you know, pretty well-defined proxies in your environment, that can definitely make it more difficult for attackers in some cases. It's going to have this little kind of basic randomized obfuscation key. Then it's going to say, download the string from this. And again, this is kind of like a little souped up version of what that little download Cradle thing. Then it's going to binary XOR all the stuff that comes back, get the text, and invoke expression on it. So very similar to that kind of pattern, just user agents, proxy aware, some of those kind of things. The negotiation stager itself, and again, I wrote this a year and a half ago, soon after I started writing PowerShell, or a year after I started writing PowerShell, so I'm sure it's terrible. I'm going to go rewrite it and make sure it's all nice and standard compliant. But it uses AES in the back end, does the encryption keys, the initialization vectors, all that kind of stuff. See what else. Oh, the one thing that was really hard to get it to play nice was exporting an RSA encryption key from PowerShell and then being able to import it into Python and getting the crypto to play well between each other. So I had to like export it to XML and like re-import it and all that kind of stuff. So it's gonna, I don't know, nothing too crazy, just AES in the back end, RSA for the provider, and the same kind of, you know, proxy settings, default credentials, all that kind of stuff, fake out the headers again. Yeah, it's nothing too long. The one thing we do is when it's actually run on generated as a launcher, we randomize the casing and we change the spacing and stuff like that, to where our idea with a lot of the ways we do obfuscation is not to prevent incident responder or reverse engineer from figuring it out. It's very easy to figure out, but our general goal on engagements is to show that automated products are not always the silver bullet. So we try to obfuscate to get by some automated products, but we do not put like anti-reversing in or like, you know, any of that kind of stuff. So again, we're not trying to create like a next generation rootkit that, you know, anyone, you know, the worst attackers can use and can't detect anything. So then the agent itself, Invoke Empire, it's got, you know, different configuration options and just, it's a PowerShell script. So it's just loaded into memory and then loaded into memory over an encrypted stream. Again, it's nothing kind of revolutionary, it's nothing too crazy, it's nothing that probably most people here could write if they were inclined to. We are pretty convinced that something like this very likely existed in the wild beforehand and just nobody really talked about it. One of my favorite sayings that I've heard in the past few years was from, is that not working? Oh, I'll just leave it like this for a second. I got like 2 more slides. Is if you can imagine it, it's probably already been done from an offensive context. So if you think, oh, it'd be really crazy if maybe something like this would work, imagine if you had 100 really, 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 really smart people and millions and millions and millions of dollars. Like, you're going to actually get it done. And those types of people that build that stuff do not come to conferences to talk about it with everybody. So, like, I very much believe that a tool like Mimikatz, or golden tickets, or whatever else, have existed for years and years and years in the wild, and attackers have used them for years and years and years, just nobody was aware. So some people on kind of the DevOps side or the defensive side will vilify people on the offensive side that release these tool sets, but the security of Windows is significantly better now. It took years, but it's significantly better because Benjamin Delpy released this. Now, there's obviously collateral damage to where attackers would use these tool sets, and you're kind of raising the average sophistication level of some of these people. But if the offensive side does not release and share a lot of this information, then things will probably get better, but they're not going to get better as fast as they could because people just aren't aware of what's actually possible. So detection with Empire. So network-based detection, you have high entropy byte strings in the HTTP post and gets. There's a standard set of request URIs like that index.asp and stuff, and those are modifiable, but the defaults in Empire actually have source fire and snort signatures that were written about a month after Empire came out. There's also really, I'll talk about this in the host in a second. If you do like netflow and heuristic analysis, a lot of this kind of malware command and control traffic will really just pop out and look very obvious. On the host side, this is where it's really fun. Command line logging, even third-party tools like Carbon Black, Bit9, a lot of these protection tools that audit what is actually being launched, and then if you can take all that data and ingest it across a large enterprise, anytime you see PowerShell-ENC, it should be a giant red flag. But, getting all that at scale and processing at scale for very large corporations is a very, very, very difficult problem, and also getting people to react to it. To where if you're just looking at the security logs at the end of a week, that's not fast enough. We have gone up against offenders that had these protections in place, but the response cycle is about 24 hours. So we constantly just changed up, and they knew we were there, but they just couldn't react fast enough. So it's about closing that kind of detection loop and that decision loop that lets you really start to react to a lot of these guys much faster. Then if you see .NET assembly is loaded up into odd processes, that's really, really weird. PowerShell 5 is awesome. Again, script block logging, you can enable super verbose script block logging, which will log out the entire Empire agent itself to the event log, so that's going to look really, really weird if you're checking for that. And the new AMSI interface, which exposes the ability for antivirus engines to scan interpreted scripts is kind of how I understand it, which I'm sure someone else can probably explain it better, much better. But it's going to open up kind of in-memory detection for not just PowerShell, but I believe like VBScript and different scripting languages on Windows 10. So AV engines, now that they're able to hook in, they're going to start writing signatures. Detection is going to get much better against this type of stuff. Again, not 100% silver bullet, but it's going to be an incredibly powerful tool. That little IEX and all that stuff in memory, like the new AMSI will be able to catch all that, from as I understand it. So summary, PowerShell Turing complete. You can write fully functioning malware in it. Real bad guys have been using this stuff for years, and we're trying to bring kind of awareness to the problem for a lot of enterprises. There's a huge amount of public stuff with PowerSploit that's already been out there. Empire essentially functions as a weaponization vector. You can run full PowerShell scripts and malware without powershell.exe, even in unmanaged code. So, any questions? Yes.
Wait a minute.
Yes, so
Sorry, just for the recording.
Yep.
Can we have? Okay.
Yeah, so my question was, you mentioned that you don't need PowerShell.exe, but I assume that you still need to have PowerShell on the box, right? So it's
or you need the
so DLLs like
you do need
system.out
PowerShell
automation.
and .NET and everything. Like this won't work on Windows XP. This won't work on Server 2003.
Well, XP can have PowerShell, but yeah.
One other thing I didn't mention is it's all version 2.0 compatible. So, and I'll talk more about this tomorrow, but in the offensive community where we can't make assumptions about the type of system that we're going to gain access to. So there's still a huge amount of Windows 7 out there. We don't want to write a tool in V3 or V5 and have it not work. So we're this weird kind of little, the black sheep of the family, I guess, in the PowerShell community, to where we have to write everything to be V2 compatible, no matter how painful it is. So we can't take advantage of a lot of the really cool new features from an offensive context. Cool. Any other questions? Oh. Uh-oh. Now I'm nervous.
No, I just wanted to underscore two things. First is, as is mentioned, we know of, PowerShell's now been out for 10 years, right? 10 years, and it's one of the most powerful things, right? It's on all the systems, it has a remote API, etc. To date, we know of no exploits from PowerShell.
Yep.
Everything that you hear is about post-exploitation, that someone else found a hole, and then when they exploited that hole, they were on the system, they could do anything they want, they had the choice of tools. Just turns out writing stuff in C++ is hard, writing in an assembly is hard, writing in VB script, you'd rather shoot yourself in the head. Malware guys have their choice of tools, and they have exquisite taste in tools. They use PowerShell. So that's one thing to have in focus. The other thing is, I absolutely agree with this, your assessment on the offensive toolkits. I'm very friendly to those. Look, there is security, and then there is hope, fueled by ignorance. Much of us think we are secure, but what in fact we are just hoping that we're secure, and that hope is fueled by ignorance. Edward Snowden, like him, hate him, Edward Snowden proved that all of these things that as, personally I'd hear these security guys come up with these theories and I just like, you know, you're out of your mind, right? Just no way. And the answer is no. They really exist. Those people are using it. It's not science fiction. It's not fantasy. The illusion, the hope of security is destroyed by our ignorance going away because of disclosures of Snowden and great tools like this. Look, I hate the fact that now dopes, look, it's one thing to have a secure nation state with billions of dollars exploit your system. Now with these tools, dopes can exploit your system. But the reality is you weren't secure. You weren't secure with those things. So highlighting these things, you know, we pay a lot of attention to it. Indeed, they fuel our investments. Things will get better over time. So, you know, I just thanks so much for doing this stuff. I think
I appreciate it. That means a lot.
It destroys the illusion and hope of security when in fact there isn't.
Cool. Any other questions? All right. If you guys want to talk about any security stuff or, you know, punch me in the face for writing this or something, you know, you can find me getting coffee during the break. So thank you so much for letting me come out here.